All right, this is the second to last video. I'm going to work through questions number 43 through 46. And this first question reads, from the balanced chemical reaction in the previous problem, what mass of H2O can be generated if 4 moles of O2 react with 15 moles of C6H5COOH? Now, this balanced chemical reaction is shown here. 2 moles of C6H5COOH plus 15 moles of O2. The question that's being asked is, where we're going is we've got, or what we're really getting at is which is our limiting reactant. 4 moles of O2. Our chemical reaction is, sorry, just a second. It was 2C6H5COOH plus 15 O2 yields, my memory is not so strong, 14 moles of CO2 and 6 H2O, 14 CO2 plus 6 H2O. I'm going to scroll back and check again because I didn't write it down. 6 H2O. Good. Okay. So where this problem has a little bit of a wrinkle, though, is we're asked about mass of H2O that can be generated. We've got 4 moles of O2 and 15 moles of C6H5COOH. Okay, so this question requires us to figure out which is our limiting reactant. We know that if we have 2 moles of C6H5COOH, we need 15 moles of O2. Do we have 15 moles of O2? We don't. A quick and easy way to solve this problem and identify your limiting reactant is to take the number of moles that you're provided with and divide it by the coefficient and come up with a nice little ratio. So the way that that's going to look is I'm going to take the number of moles of O2 that I'm provided with, 4 divided by 15. And I'm going to get 0.27, I'll call it. Okay. Then what I'm going to do is I'm going to take the 15 divided by 2. And I'm going to get 7.5. Whichever number is the lower number, that is your limiting reactant. So in this case, it would be O2. O2 is my limiting reactant. Okay, now with that understood, what I can do is I can say 4 moles of O2. I don't have to worry about the C6H5COOH. Now what I can do is look at my ratio between O2 and H2O and say 15 moles of O2, 6 moles H2O. Now I need to get the mass of H2O, so I'm going to say 1 mole H2O, which has a mass of 18 grams. That 18 grams, that comes from the periodic table. 16 for oxygen, and then 1 for each hydrogen. So 4 times 6 times 18, divide that by 15, and I get 28.8, which my best answer after that is going to be A, or 29 grams. Okay. Question number 44. Mark that off, actually. A. From the balanced chemical reaction in question number 42. Got it right here again. And I'll just go ahead and copy it. Oh, yeah, there we go. Okay. How many molecules of H2O are produced if 15 moles of O2 react with 4 moles of C6H5COOH? Okay, so this is again reliant on our balanced chemical reaction, but the tricky part about this is we're introducing and we're asked about how many molecules are produced. So this is going to have to do with the mole to molecule conversion. Now, seeing that we have 15 moles of O2 and 4 moles of C6H5COOH, O2 is our limiting reactant because we have more C6H5COOH than we need. So we can set up a balanced chemical, or we can set up our reaction to say 15 moles of O2. I'm asked about molecules of H2O. So I'm going to say 15. So this is what I was provided with from this part of the problem. 15 moles of O2 to 6 moles H2O. So that 15 here is this 15 right here. This 6 here is this 6 here. 1 mole of H2O. Well, I'm not going to grams because I'm asked about molecules. That 1 mole of H2O is equal to 6.02 times 10 to the 23rd molecules. So what I have to do is say 15 times 6 times 6.02 times 10 to the 23rd. And then divide that by 15. And I get, 15 times 6 times 6.02 times 10 to the 23rd. By 15. I get 3.61 times 10 to the 24th. Oof, I did not do a good job. Yeah. Okay, well, credit, because I didn't give you a right answer as an answer option. So 3.1 or 3.61 times 10 to the 24th. So everyone's going to get credit for number 44. Question number 45, our second to last question here is balancing a chemical reaction. Na2S2O3 plus I2 yields Na2S4O6 plus NaI. Okay, the thing that I recognize that stands out is this I2, iodine. There's 2 iodines on the left-hand side of the reaction, then there's 1 on the right-hand side of the reaction. So I'm expecting that there's going to be a 2 here. That means that I now have 2 sodium. There's 2 more, so that gives me 4 sodium. Well, if I put a 2 right here, then what I'm looking at is now I have 4 sodium. I've got 4 sulfurs, but I already have 4 sulfurs. I've got 6 oxygens, but I've already got 6 oxygens. So I'm balanced with 2, 1, 1, 2. I think that's a Rush album. But also, number 45, the correct answer is D. Okay. Number 46, our last question. Our last question for this video. I'll do one more video with the last questions. The combustion of ethane in the presence of O2 produces carbon dioxide and water. The balanced chemical reaction is shown below. How many grams of CO2 are produced when 22.6 grams of ethane are burned and 22.6 grams of oxygen? So this balanced chemical reaction is the same one that we've looked at previously. What we're trying to figure out with this question is we've got to figure out which is our limiting reactant. So what we need to do in order to solve this problem is we need to convert our masses, 22.6 grams of ethane, into number of moles. And we need to convert the mass of oxygen into the number of moles as well. So 22.6 grams of C2H6, 1 mole of ethane is roughly 30 grams. And I know that because each carbon is 12 and 6 hydrogens, each one is 1. So 12 times 2 plus 6 is 30. So 22.6 divided by 30 is 0.753 moles. Okay. Next up is 22.6 grams of oxygen. Well, 1 mole of O2 is 32 grams of O2. So 22.6 divided by 32 is 0.706. So that's our number of moles. Now what I need to do is divide each of these by their coefficient. 0.753 divided by 2 is 0.3765. 0.706 divided by 7 equals 0.1008. Okay. This number for O2 is lower. Therefore, this O2 is our limiting reactant. I figured out the number of moles, and then I divided each one of them by their coefficients in the balanced chemical equation. So by figuring out that O2 is our limiting reactant, now what I can do is I can say 22.6 grams of O2. And now what I can say is, well, 32 grams of O2 is 1 mole of O2. I'm asked about the number of grams of CO2. So what I need to do is I need to look at my ratio. 7 moles of O2 produces 4 moles of CO2. Again, I don't care about the ethane because that is in excess. 1 mole of CO2 is a mass of 44 grams of CO2. I get 22.6 times 4 times 44 equals, divided by 32, divided by 7. And I get 17.75, or the best answer for that, answer option C, 17.8 grams. Okay, so that marks the end. That is answer option C. That marks the end of this last grouping. And in the next and last video, I will cover the last parts of this exam. All right, have a